One of the first forms of pyrotechnics was used by the Greeks in ancient times. They would take an arrow and soak the end in a flammable substance such as oils or tar or pitch, and it could be hurled manually at the enemy as a scare tactic. These technically weren't considered pyrotechnics because they had to be manually hurled at the enemy. Here we have a flaming arrow like the Greeks would use.
As early as 492, Chinese alchemists noted that potassium nitrate burns with a purple flame. And this later went on to become one of the key ingredients in gunpowder. At approximately 1040, the first formula for gunpowder was developed. It was about 50% potassium nitrate. This early form of gunpowder was used primarily for fireworks, and it wasn't until years later that the Chinese had a storage building filled with black powder that exploded and sent heavy beams up to 2 miles away that they realized its weaponized potential.
In order for a redox reaction to occur, there has to be both a reducer and an oxidizer. In black powder, sulfur is the reducer and potassium nitrate is the oxidizer. These two are mixed together and, when burned, create a redox reaction that burns rapidly, like so.
Reducers and oxidizers need to be in the correct mixture in order for the redox reaction to burn well. For example, burning wood happens relatively slowly because the reducer oxygen is not mixed within the wood. However, if you throw sawdust up in the air and ignite it, it'll burn much more quickly because the oxygen is mixed with the sawdust. So this little pile of sawdust will act as our wood, which you will see burns relatively slowly. See, it's burning, but it's fairly slow. Slow going there because the oxygen is not mixed well within the wood that's burning. However, when the sawdust is thrown into the air, it mixes with the oxygen and it'll burn much more rapidly. In fireworks, there are two explosions. The first is to elevate the capsule into the air to get the height above the spectators, and the second is to produce color.
In fireworks, various elements produce various colors. For example, white can be created with magnesium or aluminum, sodium salts produce yellow, strontium nitrate or carbon make red, barium nitrate creates green, copper salts for blue, and charcoal or other forms of carbon to make orange. Here we have strontium. When burned, it will create a reddish color. Why do we need 7 points?
Today we're making gunpowder, which more or less consists of 75% potassium nitrate, 15% charcoal, and 10% sulfur. It is very important that all the materials get ground together thoroughly, so that in the end, everything gets mixed together better. Here we have an open burn test to make sure the gunpowder we made burns fairly successfully. When gunpowder is packed together more tightly, the oxidizers and reducers are closer together, thus producing a faster burn rate, as you can see here in our capsule.
So bad.
So here we have store-bought black powder in pellet form, and we're going to do an open burn test to see how it burns and compared to the stuff we made in class.
As you can see, the store-bought gunpowder burned much more rapidly because the ingredients were more finely ground together.
So this is our first black powder vessel. We're going to throw it in the fire pit and light it and see what happens. Oh. For our next size up, we have a tennis ball filled with black powder, and we're going to light it and see what happens. Oh. Black powder explosions follow the path of least resistance, which is why our explosion went right at the top and shot a fireball about 30 feet into the air. For round 3, we have our final explosive device here, and we'll light it off and see what happens.
Aftermath from the explosion. You can see the explosion just blew the whole top right off, including the label. It sent it probably like 30 feet up. You can see the rest of the can still seems to be intact though.